Today we're going to continue on our proofs unit. This is, I'm going to refer to some postulates, definitions, and theorems on the back of this page right here. So we gave you this page when we started the first unit, and on the top we talked about midpoint, segment, bisector. Then we went into angle addition postulate. Yesterday we talked about the logic notes, so we've talked about the bottom, so from logic notes down. So today we're at the top of this page, so this page has served its purpose for 2 units now, going into the third. And these are some things that we just want to reiterate to you before we start looking at geometric proofs. So some things to remember: through any 2 points is exactly 1 line. Through any 3 non-collinear, so refer back, non-collinear means they're not in a line. So any 3 non-collinear points, there's exactly 1 plane. So again, a line contains at least 2 points, so do you see how these are just reversed? A plane contains at least 3 non-collinear points, so again, these are just reversed. Space contains at least 4 non-collinear, non-coplanar points. So think of students in a classroom, 4 non-collinear, non-coplanar. If 2 points lie in a plane, then the line containing those points lies in that plane. If 2 points lie in a plane, then the line containing those points lie in a plane. If 2 lines intersect, then their intersection is exactly 1 point. So think about when you're driving your car and you get to a red light, that's an intersection of 2 roads. The roads could look like lines. But if we're talking about 2 planes, their intersection is a line. So think about walls in a classroom. Your ceiling and the front wall, where they meet, form a line. All right, so these are some postulates and theorems and definitions that we will refer to quite often when looking at a geometric proof. All right, so now I'm going to switch gears. This is the first worksheet that we have in our proof unit. It says proofs, assumptions, and justifications. So if you want to get this worksheet out, or if you want to print it from online and have this in front of you, I have the typed notes for things that you can assume from a diagram and things you cannot assume. So we talk quite often in class about never assume an angle measure, don't just guess, but there are some things that you can look at and know without a doubt, based on the diagram, what those things could potentially be. So again, I'm not going to write these. I have these printed out, so if you need to get this paper in front of you, take a second, stop your video, and pull that out. All right, so at the top of that worksheet, things you can assume from a diagram. All right, so we can assume that angles are adjacent. Remember, those are neighbors. They share a ray. We can assume a linear pair because linear pairs are 2 adjacent angles whose non-common sides form a line. And we can assume vertical angles because vertical angles are formed when 2 lines intersect. So you can look at a diagram and you can identify adjacent, linear, or vertical angles. All right, and the second thing we can assume, that points and rays are collinear. Remember guys, we can see if they form a line. Collinear means they're all in a line. We can assume a point is between 2 other points. Notice I did not say in the middle. I said between 2 other points. And we can assume that a point is in the interior of an angle. Interior means inside. We can assume that points and lines are coplanar. And we can assume that 2 rays are opposite if they form a straight line. We can assume that 2 rays are opposite when they form a straight line. Those are things you can assume. You can look at a diagram and you can know these things. But I think sometimes we need to focus more on the things we cannot assume. The things we cannot assume. We cannot assume segments or angles have a specific length or measure. Guys, you can't just look at that angle and say, well, he looked like he was 90. No, no, no. Never assume a segment or angle length or measure. We cannot assume that an angle is a right angle. No, that's doing the same thing as number 1. Even if it looks like an L-shaped graph, an L-shaped angle, do not assume a right angle. We cannot assume that segments are congruent or angles are congruent. Again, we're doing exactly what we said not to do in step 1. We cannot assume that lines are parallel, even though they may look like railroad tracks. We can never assume that they're parallel or perpendicular. These are things that we have to prove algebraically or in our proof, okay? So for a proof, these must be in the given. So we've got to tell you these things. You cannot assume these things. So again, these are the 4 steps that you should have written down at the top of this worksheet here. Okay? All right, so speaking of that worksheet, let's move into 1 through 6. And we're going to practice those exact things that we just wrote above. Because it says, for each picture, what can you assume? Okay, so looking at number 1, we can see that angle 1 and 2 share a ray. So the first thing that we know is angle 1 and angle 2 are adjacent. We know that simply by looking at that picture. And also, their non-common sides form a line, so not only are they adjacent, but they are also a linear pair. Okay, number 2. Now we have a line with some points on it. So we can easily see that these 3 points are in a line. So therefore we can say that A, B, and C are collinear. We can easily see that. They're all 3 in the same line. We can also say that B is between A and C. Notice I did not say in the middle, I said between. And I also know that part plus part is equal to the whole thing. So therefore I can say AB plus BC would give me the whole line of AC. So we can take away quite a few things from number 2. So guys, number 3, this is what I was talking about. Number 2 and what you cannot assume that an angle is a right angle. Everything in our being wants to say that that's a right angle because he's nice and L-shaped. Guys, we have no idea what his measure is. The only thing that we can take away is that these 2 angles are sharing a ray. That's it. So the only thing that we can say is that they are adjacent angles. That's it. Oh, but look at number 4. I'm going to zoom in on him just a little. We have a lot going on with number 4. So I'm going to start here on the bottom, and you'll see me often do this right here. So I can see that 8 and 9, so angle 8 and angle 9, first I can see that they are adjacent angles because they share this ray, but then their non-common sides form a line, so I also know that they are a linear pair. So I know that 8 and 9 are adjacent and they form a linear pair. So let's kind of work our way around. So do you see that we could also draw the line here for angle 9 and 5? So I could do that right here. So same thing, angle 5 and angle 9 are adjacent and they form a linear pair. Alright, let's keep working around. So let's look at 5 and 6. Again, a lot of people are going to want to say that they're a right angle, but guys, we don't know anything about their measure. We know nothing about any of these guys' measure. So the only thing that we can say for 5 and 6 are that they are adjacent. They share a ray. That is the only thing we can take away from that diagram. All right, so keep working. Do you see that the same thing goes for 6 and 7? They just share a ray between them. So the only thing that we can say is angle 6 and angle 7 are adjacent. Seven and 8. Here's 7 and 8. Notice it doesn't form a straight line, so we can't say that they're a linear pair. The only thing that they do is share a ray. So angle 7 and angle 8 are adjacent. And then one last thing, a lot of students, because if you are a visual learner like myself, sometimes it's hard for us to notice that angles 5 and 8 are vertical, because they're not straight up and down in a nice little X method like we like to see them. So a lot of times we will overlook that guy. So angle 5 and angle 8 are vertical. So notice nowhere in there other than these two could we decipher, well, we know a linear pair is supplemental, which means that they're 180, but everybody else we know nothing about their angle measures. All right, number 5. Guys, we're kind of back to like number 2, right? It doesn't say anything to us about what M is. He looks like he's dead center between D and F, but we don't know that. The first thing that we can visually see is that D, M, and F are collinear. We can see that M is between D and F. And we can see that part plus part is equal to the whole segment of DF. All right, so here, number 6, the only thing that we can say about these guys is that they share a ray. So we could say that angle 10 and angle 11 are adjacent. But guys, if I gave them some points, so on your paper, let's label these guys A, B, and C. So now do you see that angle 10 plus angle 11 would give us the entire angle of ABC? So the measure of angle 10 plus the measure of angle 11 would equal the measure of angle ABC. And we got that simply because I gave the angle some points. All right, so that's what we can assume based off of those diagrams. So what you're going to do from 7 through 13, based on the picture alone, determine if the statement is true or false. So guys, it's going to ask you to put these definitions into play over here. Like, how well do you know your definitions? All right, so B, C, E, C, D are a linear pair. So we're doing true, false. So remind yourself, linear pairs are adjacent angles whose non-common sides form a line. Well, we can visually see that, and we can assume linear pairs. So therefore, that guy is true. All right, so I talked about this guy last night with the student in tutoring, and we talked about an upside down T means perpendicular, and perpendicular means 90-degree angles. So where these two lines meet form a 90-degree angle. That's what this is saying. Line AB is perpendicular to line BC. So line AB perpendicular to BC. Do you see that this notation here, where those two lines meet, is your right angle notification? So therefore, we could say that's true. Based off of this guy right here, where those two lines intersect form a right angle. So again, you have to understand the definition of perpendicular. All right, ABE, EBC are complementary. Remind yourself, complementary angles, the sum of two angles is equal to 90. So could we say this angle plus this angle equals 90? Yes, based off of this right here. Therefore, we could say it's true. Now, keeping with those same two angles, ABE and EBC, can we say they're congruent? Remind yourself, congruent angles mean they're equal, which means their measures are equal. Do we know anything about the measure of each of those? No. We only know that if we add them together that they give us 90. Nowhere in there did I say that they were 45 and 45. We have no idea what they are. So guys, we cannot say that that's true. We aren't sure. We have no way of knowing by looking at that picture. ECB is 90. Guys, we have no idea. Nothing sitting there tells us that it's a 90-degree angle. But we're going to want to say true with everything we have because it looks like an L-shaped angle. No, no, no. We have no idea what he is. C is a midpoint of BD. C is a midpoint of BD. Guys, we have no idea. We have no idea if he's dead center. But what do we know? We know that C is between B and D. He's between, but we don't know if he's dead center. He might be off by 1/10 of a point. All right, look at this guy. BD is parallel to AE. BD is parallel to AE. Guys, if you look at just those two lines, don't they look like railroad tracks? And you say, well, it doesn't look like they ever meet. Why can't I say they're parallel? Because this is the marking for parallel. So here we have perpendicular. Here we have parallel. And everything about that drawing is going to want to make us say true. But unless we are told that they are parallel, we cannot validate that. All right, so today we've talked about things that we can assume and things that we can justify. All right, so your homework from page 131 and from page, just from page 131 will help you practice some of these right here and also help you practice some of these definitions, postulates, and theorems to get you into a routine of being able to notice what you can and cannot assume about a proof.